In this video, we're going to make an API request to this website's open access API, fetch the data, process it, clean it, and do some exploratory data analysis. First, I will launch a Jupyter Lab notebook, rename it, and start our analysis. First and foremost, we need to install the dependencies. To make an API call, you need to install this requests library. To install it, this is the command. I'm not installing it because I've already installed. Next, I would import all the necessary libraries. Next, I would connect to the API using a GET request. Response is requests.get and the URL. This data is a collection of artwork of African American artists. So I would call it CAM collections. Now, when you request data to an API, the data is usually delivered as a JSON object. And when we use .json method on this response, what it does is it converts the API response into a Python dictionary. We can also use json.loads of response to convert it to a Python dictionary. I'm checking the type of the CAM collections object. It is a dictionary. So this response.json converts the JSON object received from this API into a Python dictionary. Let's look at the length of the dictionary. That means there are 2 keys and values in the dictionary. Let's check the keys of the dictionary. CAMCollection.keys. So this dictionary has 2 keys, info and data. Now let's check what data is there in the info key of the dictionary. This is talking about the actual information of the dictionary. It has a total of 1048 parameters. It is of African American artists and so on. So this information is not required for us. We look at the actual data. Now let's extract the first item in the CAM collections data field. Okay, so this is the first item. It has an ID, it has an extension number, it has a license status, tombstone, and so on. Let's use pprint on this data point to make it more readable. Okay, so this is more readable now. So each data point is again a list of dictionaries. Now, how did I say it's a list? Because each data point is enclosed in square brackets and within it are the curly brackets. That's how I say it's a list of dictionaries. So this is one data point. Let's check the type of each data point. Now I want to convert this to a Pandas DataFrame. As I told you, this is a Python dictionary. We could directly use pd.DataFrame to convert it to a data frame. But the problem is this JSON structure has some nested fields inside it. For example, if you see at citations, there are many nested structures inside the citations key. So if we directly use pd.DataFrame of CAM collections of data, it will keep the nested fields intact as lists or dictionaries, which will make my further analysis difficult. To get over this problem, I would use a method called JSON normalize, which actually pulls out these nested fields into separate columns, which makes me easier to work with the columns. This is the API documentation for JSON normalize. pd.JSON normalize. These are the parameters. So if you look at an example of this, let's say, so this is the data. It is similar to our data. It is a list of dictionaries. So here, pd.JSON normalize. The first input is data, which is a list of dictionaries. So this is one dictionary and this is the second dictionary. Now within each dictionary, there is a key value pair called counties, which is again a list of dictionaries. Now when we do pd.JSON normalize, the first input is the data, which is a list of dictionaries, and the second input, counties, what it does is it expands these counties into separate rows. For example, if you see the result, the name and population have come into columns here. That means these counties have become rows. The first 3 counties are coming here, and the next 2 counties are coming in the next rows. So it expands the counties into separate rows. And the next argument in square brackets state, short name, info, and governor, it extracts the parent level attributes like state, short name, and repeats it for each row. For example, in the first dictionary, we have these 3 counties and those belong to the state, short name, and info. So when I expand these into the rows, these things should be repeated. It's almost like a one-to-many relationship. So each county has the state, short name, and info dot governor extracted and repeated for all the rows. So this is what is done by JSON normalize. We're going to do the same thing for our citations. We want the citations which are in the nested dictionary to be in the rows of the data frame, and some of this data I want it as other columns in the data frame. So I'm creating a data frame by flattening the CAM collections of data using JSON normalize method. So I'm calling the data frame ccdf is pd.JSON normalize CAM collections of data. This is the first argument. As you could see here, data is the first argument. The next argument for me is citations. As I told you, I want these citations to be on each row, and I want to pick up the other columns as accession number, title, creation date, collection, creators, and type. So these are the other columns I want for each citation. Close the bracket, run it. So the data frame is created. I want to check the head of the data frame. So we got each citation here, and the citation object has page number and URL. So those things are coming into columns. And then we have the parent dictionary items like accession number, title, creation date, collection, creators, and type. So creators, you could see this is again a list of dictionaries. The entire list is saved as a record for each citation. Now we could look at the data from a different point of view by transposing the data frame, that is to interchange rows and columns. To transpose the data frame, this is the method .t. When you execute it, you could see the columns have become rows and rows have become columns. Now I want to extract the creators column and check what the data is. Let's check the first 2 data points. So these are the first 2 data points. Let's check the first item of the creators column. So this is the first item of the creators column. It has an ID, description, extent, qualifier, role, biography, birth year, and death year. Now I want to extract the description of the first creator for each citation and append it to this data frame and calling it creator1. To do that, I'll use a Lambda function and apply it to all rows. Lambda x of 0 is the first creator, and first creator's description is extracted and it is applied to all rows, and it is appended as creator1 to the data frame. Let's look at the head of the data frame now. So we could see the creator1 is appended to the data frame. I would add one last important thing. So when we were downloading this from the API, we don't know what's the memory of this response. So once we convert that into JSON, we could find the memory of CAM collections by using the below command. First we should install pympler, and then from pympler import asizeOf. Now we use the method asizeOf cam collections to get the total size of the dictionary in megabytes. So the cam collections object which we downloaded from the API is of memory 8.52 MB. So that's how we could connect to an API, download the data, and clean it to do analysis using Python. That's all for this video. Thank you for watching.